Welcome to the dawn of a new energy era. This massive Gigafactory stands as a monument to human ingenuity, redefining how we power our future world. In this high-tech sanctuary, the fusion of architecture and sustainability creates a seamless production environment where clean energy is the absolute and only priority today. As the automated doors glide open, we step into a sterile world of perfection. Every inch is maintained by advanced robotics to ensure a contaminant-free environment. Silent guardians of purity, these autonomous units work tirelessly to maintain the air quality and surface cleanliness required for the delicate process of lithium battery manufacturing. Deep within the heart of the facility, the central AI brain monitors every single variable. Data flows like a digital river, optimizing every millisecond of production. Human oversight meets artificial intelligence here. Command centers utilize holographic interfaces to track the complex pulse of the factory, ensuring peak performance at every single station. Behold the massive reservoirs of the future. These towering silos hold the precious raw materials like lithium and cobalt that form the chemical foundation of energy. Through a complex network of silver pipes, these rare elements are transported with surgical precision. The journey of a battery begins with the movement of elements. Quality control starts at the atomic level. Robotic arms extract samples for testing, ensuring that only the highest grade materials enter the highly sophisticated production cycle. The flow of progress is visible as minerals race through transparent conduits. Every gram is accounted for, moving toward the next phase of its incredible transformation. Purity is the ultimate goal. The digital displays confirm that our raw ingredients have reached the absolute standard required to power the most demanding electric vehicles. The mixing process begins as fine lithium powder cascades into the vat. It falls with a silk-like grace, ready to be blended into a powerful, energy-dense slurry. Massive industrial blades churn the mixture, combining solids and liquids into a uniform paste. This slurry is the lifeblood of the battery, carrying the potential energy. Notice the perfect viscosity and the glossy sheen. This dark viscous fluid represents the culmination of chemistry and engineering, designed for maximum conductivity and long life. Synchronization is key. Robotic arms move in a rhythmic dance, ensuring that every batch of electrode material is identical in its chemical and physical properties. The black anode slurry travels through specialized glass pipes. A vacuum system removes every tiny air bubble, preventing future defects and ensuring a perfectly dense material. Parallel to the anode, the silver-gray cathode mixture is prepared. This dual-track process ensures that both essential components are ready simultaneously for the next critical stage. Precision sensors glow with approval as they confirm the chemical balance. In this factory, there is no room for error, as every micron of material counts. Heavy-duty pumps pulse like a mechanical heart, driving the slurry forward. The material moves with purpose, nearing the stage where it will take its physical form. The mixing hall is a cathedral of chemistry. Its vast, controlled environment allows for the massive scale of production needed to meet the global energy demand. Every adjustment is minute and precise. Even the smallest valve turn is handled by robotics to maintain the exact pressure and flow rate for the slurry. Advanced filtration systems catch the invisible. By removing microscopic impurities, we guarantee the safety and reliability of the energy cells that will eventually power your car. Laser sensors keep a watchful eye on the storage buffers. This constant monitoring ensures a steady supply of material to the coating line, preventing any production delays. Homogenization creates a perfectly uniform texture. This hypnotic swirl ensures that the active materials are distributed evenly, providing consistent power across the entire surface of the electrode. The signal is given. The slurry is ready. We have achieved the perfect blend of chemistry and physics, setting the stage for the next high-speed manufacturing step. We transition now to the coating bay. The environment shifts as we move from liquid chemistry to the world of high-speed thin film application and precision engineering. Massive rolls of copper and aluminum begin to spin. These ultra-thin metallic foils serve as the current collectors, the foundation upon which the energy layers are built. The copper foil moves with incredible speed and tension. Its mirror-like surface must be flawless, as even a tiny speck of dust could compromise the entire battery. The digital coating head applies the slurry with absolute precision. A uniform layer of energy-active material is spread across the foil, measured down to the last micron. The comma coater blade works with surgical accuracy. It maintains a constant thickness throughout the process, ensuring that every cell produced has the exact same energy capacity. The coated foil enters the drying oven, a tunnel of intense heat. Here, the solvents evaporate, leaving behind a solid, high-performance layer of active material on the foil. Inside the oven, infrared heaters glow with power. The temperature is tightly controlled to prevent cracking, ensuring the structural integrity of the electrode as it solidifies quickly. As it exits the oven, the transformation is complete. The liquid slurry has become a solid, matte black coating, now ready to store and release electrical energy efficiently. Massive calendering rollers compress the electrode under extreme pressure. This process increases the energy density, packing more power into the same physical space for better battery performance. Real-time sensors monitor every pound of pressure. This delicate balance between force and precision ensures the material is compacted perfectly, without damaging the thin metallic current collector. Precision slitting begins as high-power lasers slice the wide rolls into narrow strips. The edges are perfectly clean, preventing any short circuits during the final assembly process. The power of light is harnessed for manufacturing. Watch as the laser carves through the metal with microscopic accuracy, creating the exact dimensions needed for individual battery cells. Finished strips are collected by swift robotic arms. They are organized and loaded onto autonomous vehicles, moving seamlessly to the next stage of the automated production line. The journey continues as we move toward assembly. Every batch is tracked digitally, ensuring a complete record of its manufacturing history from the very first drop of slurry. Welcome to the heart of the assembly process. Here, hundreds of high-speed robots work in harmony, performing tasks with a speed and precision that exceeds human capability.
Bank C activated.
Dual-arm robots perform a high-speed stacking dance. They layer anode, separator, and cathode with incredible velocity, creating the internal sandwich structure that stores the battery's energy. Alignment is critical to safety. Green lasers and optical sensors verify the position of every single layer, ensuring perfect centering to prevent any potential internal electrical faults. In the winding station, the layers are spun into a tight, perfect cylinder. This compact design is the secret to the high energy density of modern cylindrical batteries. The wound core is inserted into its metallic housing. The fit is engineered to be perfect, providing a robust shell that protects the delicate internal components from damage. A flash of blue light signals a permanent bond. Laser welding seals the bottom of the casing, creating a hermetic seal that will last for years of service. X-ray vision reveals the invisible. Every cell is scanned in 3D to ensure there are no internal defects or contaminants, guaranteeing the highest safety standards for the user. The cells enter a vacuum chamber where air is removed. This preparation is essential for the next step, allowing the liquid electrolyte to penetrate every corner of the core. Moving in perfect rows, the cells advance through the line. This high-volume conveyor system is the backbone of the factory, carrying thousands of units toward their final completion. Robots fit the top cap and safety valves with precision. These components are vital safety features, designed to manage pressure and protect the battery during extreme operating conditions. Electrical continuity is verified instantly. A digital check mark confirms that the internal circuits are complete, and the cell is ready to be brought to life with electrolyte. The scale of production is truly breathtaking. Thousands of cells move through the assembly area every hour, each one a masterpiece of modern manufacturing and high-tech engineering. Efficiency is maximized through multi-grip robotics. Handling dozens of cells at once, these machines ensure that the high-speed pace of the assembly line is never interrupted. The injection of the electrolyte is a delicate moment. This clear liquid is the medium through which ions will travel, giving the battery its ability to store energy. Watch as the electrolyte is absorbed into the porous layers. This soaking process, known as wetting, ensures that every part of the electrode is active and ready for use. A final laser weld hermetically seals the cell. This ensures that the electrolyte stays inside and moisture stays out, protecting the battery's chemistry for its entire life cycle. The sealed batteries are moved to the formation room. Here, they are loaded into massive racks where they will undergo their first ever charge and discharge cycles. Life begins with the first charge. As electricity flows into the cell, a stable solid electrolyte interface forms, which is crucial for the long-term health and stability of the battery. Thousands of cells are awakened simultaneously. This sea of flickering lights represents the birth of energy, as each battery is carefully conditioned for its future life of service. Thermal stability is monitored with precision. High-resolution thermal cameras ensure that no cell overheats during its initial activation, maintaining the highest levels of safety and quality throughout. Every cell has a digital twin. We track the voltage and current curves for every single unit, ensuring they match the ideal charging profile for maximum performance. After formation, the batteries move to the aging area. Here, they will rest for several days to ensure their chemical stability and to detect any rare self-discharge issues. In the quiet of the aging room, chemistry settles. This period of rest is vital for ensuring that every battery delivered to the customer will be reliable and safe. Testing is continuous and rigorous. Each battery's internal resistance is measured to the milliohm, ensuring that only the most efficient cells move forward to the module assembly stage. Cells are sorted with extreme precision. By grouping batteries with identical performance characteristics, we can build modules that are perfectly balanced, extending the overall life of the battery pack. Nothing is left to chance. Any cell that doesn't meet our strict criteria is instantly diverted to recycling, ensuring that only perfection reaches the final assembly of the pack. This energy warehouse is a testament to quality. Organized, silent, and efficient, it is here that the individual cells prove their worth before becoming part of something much larger. The proven cells now head toward their final destination. They are ready to be integrated into the complex modules and packs that will power the next generation of transportation. We enter the scale of power. Module assembly is where individual cells are unified into larger structures, capable of providing the immense energy required by modern electric vehicles. Individual cells are arranged into modules. The precision of their placement is key to the efficiency of the cooling system, which will manage the temperature during rapid charging. A high-speed laser joins the terminals. Busbars are welded with micromillimeter precision, creating a low-resistance path for the high currents that will flow through the battery pack. A completed module is a marvel of engineering. It features integrated cooling